Okay, today, Assalamu alaikum. Today we are going to discuss the past paper, May-June 2023. This is variant 1, 970941, mechanics paper 1. Okay, the question number 1 is two particles P and Q of masses m kg and zero point 0.3 kg. So these particles are PQ and their masses are this one. So for particle P, the data is M1 is equal to m kg. And in the same way, Q particle is M2 is equal to zero point 0.3 kg. Are at rest are at rest on a smooth horizontal plane. P is projected at a speed of 5 meter per second. That means V1 initial, that is 5 meter per second. After P and Q collide, P moves with a speed of 2 meter per second in the same direction as it was originally moving. So V1 final is equal to 2 meter per second. And this was, Q was at rest. So V2 is equal to 0 meter per second. And now they are saying after the collision, find in terms of m the speed of q after the collision. So we have to find out v2 initial was 0, v2 final we have to find out. So let this is v meter per second, right? Okay, the formula for momentum is m1 v1 initial plus m2 v2 initial is equal to m1 v1 final plus m2 v2 final. And m1 is m kg, m into v1 initial is 5 plus m2 is 0.3 kg and v2 initial is 0 and m1 is m kg and v1 final is 2 and plus m2 is 0.3 and v2 final we have to find out, that is v. So this is 5m is equal to 2m plus 0.3 v. So v is equal to 0.3 v is equal to 3m and v is equal to 10m meter per second. So this is your answer. This is the velocity of q after collision. Okay, so this is your answer for the part A. Okay, part B is, let me, I've written it before, so let me, okay, let me discuss it with you. I just, to save time, I've noted down this data. After this collision, Q moves directly towards the third particle R. Now they are talking about Q and R. So the Q mass is 0.3 kg, that is given in the part A, we have done now. And R's mass is 0.6 kg, that is written over here. So M1 is equal to 0.3 kg and M2 is equal to 0.6 kg, which is at rest on the plane. Q brought to rest in the collision after R. So Q was moving in the last time we did in the part A, that was moving with the speed 10 m meter per second. So that would be initial velocity of the particle Q, and that would be 10 m meter per second. Its final velocity will be 0 because Q brought to rest in the collision with R. After collision with R, it will become at rest. So 0 meter per second. Okay, so M2 is 0.6, V2 R was at rest. R was at rest. So its velocity, initial velocity will be 0 meter per second, and its final velocity after collision, it started moving with the speed of 1.5 meter per second. So its final velocity will be 1.5 meter per second. Now, writing the formula M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. Okay, M1 is 0.3 into 10M plus M2 is 0.6, and velocity of initial velocity of R is V2 initial is 0, M1 is 0.3, and initial velocity of final velocity of Q is 0 plus M2 is 0.6, and final velocity of the R, which is V2 final, sorry, it's final here. Okay, it's final velocity of the R, 1.5. Okay, this will become 3m plus 0 is equal to 0, and this will become 0.90, and m is equal to 0.30 kg. So you got the mass which you were supposed to find out, that is 0.30 kg. Okay, this is question number 2. A particle P of mass 0.4 kg projected vertically upwards from the horizontal ground with the speed of 10 meter per second. Find the greatest height above the ground reached by the P. So you can say that this is the starting initial velocity given to the particle, and is projected upwards. So it will gradually slow down due to the gravitational force, and at the top, when it will achieve its highest velocity, highest point, the higher greatest height, its velocity will become 0, and again when it will go back to the ground, it will hit the ground with the same velocity it was projected with. So you have to keep this thing in your mind, that if you have projected some particle with 10 meter per second, it will hit the ground with 10 meter per second, and if some other, so that would be the same actually. Okay, so we have to find out the greatest height above the ground. So we can use the formula S is equal to V square minus U square over 2G. So S is equal to V square is 0 square minus initial velocity is 10. So 10 square over 2 times minus 10, gravitational force as it is going upwards. So the gravitational force will be negative. Gravitational force will be negative, and this will become minus 100 over minus 20. That's 5 20s are 100. So 5 meters. So it will attain the greatest height of 5 meters. So that means this distance is 5 meters. Okay. So the next part is part B. In part B, they says that when P reaches the ground again, it bounces vertically upwards at the instant that it hits the ground. P loses 7.2 joules of energy. Okay, as I told you before that when it is projected with speed 10 meter per second, so it will hit the ground with 10 meter per second again. Now it is projected again because of bouncing, and it will be again hit the ground. So we have to find out the time between first hit hitting the ground and second hitting the ground, right? So this is the time between the first and the second instant at which P hits the ground. So we have to find out the time between this journey. Okay, so first of all, we'll find out what is the kinetic energy when it hits the ground. So that was half mv square. So that is 1 over 2 into m is 0.4. So 0.4 into 10 square. So that is joules. So that is 20 joules. So when it hits the ground, after hitting the ground, after hitting the ground, the ground, it loses 7.2 joules. So that will become 20 minus 7.2. So that is 12.8 joules is left. And it now it will project with 12.8 joules. It will bounce with the energy 12.8 joules. So we'll check what would be the initial velocity. When it hits the ground with the 20 joules, and now it bounces with 12.8 joules. So we'll find out at this time what is the initial velocity. It's moved upwards, right? So 12.8 half mv square, this energy is 12.8 joules. Uh, and we'll find out the initial velocity. Mass is 0.4, u square is equal to 12.8, and this u is equal to uh, 64, and 64 square root is 8 meter per second, right? Now we have to find out with by what uh, the time between the first and the second hit. When it will hit the ground, that means at hitting time, the distance is 0. The height is 0 here, height is 0 here. Even when it started first, height was 0. And at the first bounce and the second bounce, the height is 0. So that means S is 0. So we'll use S is equal to ut plus half at square. So 0 is equal to U is 8 meter per second, T plus half into minus 10 T square. So this will become, if you take common T, so this will become 8, write it 5T square minus 8T is equal to 0. So T 5T minus 8 is equal to 0. T is equal to 0, or T is equal to 8 over 5, which is 1.6 seconds. So the the difference between the first and the second instance when P hits the ground was 1.6 seconds. That's your answer. Hope you have understood. If you have any queries, problems, you can ask me in the comment section. Okay, this is question number 3. A particle moves in a straight line starting from rest. The displacement s meter of the particle from a fixed point O on the line at time t seconds is given by this. Find the value of s when the particle is again at rest. At rest means, again at rest means that the particle is not moving. That means velocity is zero. And you know that velocity is equal to change in distance over change in time. So that is equal to ds over dt. So we'll find out the derivative of the given displacement formula. So S is equal to t raised to the power of 5 by 2 minus 15 over 4 t raised to the power of 3 by 2 plus 6, and ds over dt is equal to 5 over 2 t 5 minus 5 by 2 minus 1 is 3 by 2 minus 15 over 4 into 3 by 2, and t raised to the power of 3 by 2 minus 1 is 1 by 2 plus 0, and this is v is equal to 5 over 2 t cube over 2 minus 45 over 8 t raised to the power of 1 by 2. And you know at rest means at rest v is equal to 0 meter per second. So 0 is equal to, taking t raised to the power of 1 by 2 as common, so this will become 5 over 2t minus 45 over 8. So t raised to the power of 1 by 2 is equal to 0, or 5 over 2t minus 45 over 8 is equal to 0. So t is equal to 0. At t is equal to 0, it was at rest. That was the starting time, starting of the motion basically. Okay, and then t is equal to 45 over 8 into 2 over 5. So this will become t is equal to 5 nines are 2 fours are, and this will become 2.25 seconds. So that means next time it was at rest when the time was 2.25 seconds. Now by substituting this time 2.25 seconds in the formula, we'll find out what was the distance at that time. So we'll substitute 2.25 here. S is equal to 2.25 raised to the power of 5 by 2 minus 15 by 4, 2.25 raised to the power of 3 by 2 plus 6. So S is equal to, using the using the calculator, you'll find out that this is S is equal to 0.9375 meters. So this is your answer. This was the distance uh, when the particle was at rest. Okay, hope you have understood the concept. If there is any queries, you can ask in the comment section, and I'll try my best to answer you. Okay, question number 4. The diagram is provided. The velocity of a particle at time t seconds leaving fixed point O with v meter per second. The diagram shows a velocity time graph of which models the motion of a straight line, motion of a particle. The graph consists of 5 straight line segments. The particle accelerates at 0.9 meter per second with the speed of 0.9 meter per second. Oh, sorry. There is some issue. Okay. in the period of 3 seconds, or when this 3 seconds, and then travels at a constant speed for 6 seconds, and then comes instantaneously to rest in 1 second. The particle then moves back, returns to the point O, uh, to rest at O at t seconds. Okay, so accelerates, uniform velocity, decelerates, then goes back to point A, and this is the negative velocity. Okay, so if we say that this is V, okay, so they are saying find the distance traveled by the particle in the first 10 seconds. So first 10 seconds, it's a trapezium. Height of the trapezium is zero point 0.9. Parallel side, this is 10, and this is from 3 to 9, this is 6 seconds. Okay, the distance traveled is S is equal to 1 over 2 into height 0 0.9 into sum of parallel sides, and this is 10 plus 6, and this is 16 divided by 2, that will become 8, 8 9 is 72, 7.2 meters. So this is the answer of your first part A. Right. Okay. So we'll move to the next part. Next part is they are saying part B, given that t is equal to 12, find the minimum velocity of the particle. So if they are saying if this is 12, find the minimum velocity, this one. So can we write it as a V minimum? So this is V minimum. So what is this distance is, if this is 12, so this would be 12 minus 10, this is equal to 2. And the perpendicular height of the triangle is V minimum, right? So, and this distance, as this distance is 7.2, so when it comes back, this would also be 7.2. That means the distance covered by this graph, this triangle, is 7.2 meters. Okay, by using this, we'll find out the minimum velocity. So area under the graph and the triangle is 1 over 2 into base, that is 2 into height velocity minimum, is equal to 7.2 meters. Okay, this means that minimum velocity is, sorry, this is not distance, this is displacement, so that would be negative 7.2, because it has gone back to point O, so this will become minus 7.2 meter per second. Okay, for the second part, let me highlight this. Okay, so second part is part C is given instead that the greatest speed of the particle is 3 meter per second. Now they are saying the greatest speed, the particle cannot move more than 3 meter per second. Find the value of t, and hence find the average speed of the particle for the whole motion. Okay, so we'll go back to the diagram. Now I'll remove this. This is not like this now. Okay, this is 10 t minus, because t is not given, we have to find out. So this is t minus 10, and this is 3 meter per second speed, because the maximum speed is 3 meters per second. Okay, so 1 over 2 1 over 2 into base t minus 2, sorry, t minus 10 into height 3 is equal to 7.2. Now this is because speed, so that would be not be negative. So t minus 10 is equal to 7.2 into 2 divided by 3. So t is equal to 3 twos are 4s are 2.4, 4.8 plus 10, 14.8 seconds. So this will become 14.8 seconds. Okay, when t is hence find the average speed. So we have to find out, hence find the value of t. So we have done it. This is your first answer, which we have found in t is equal to 14.8 seconds. And next we have to find out and hence find the average speed. So average speed is equal to average speed is equal to total distance divided by total time. Total distance divided by total time. So what is the total distance? 7.2 plus 7.2 because it moved 7.2 and came back 7.2, and it is not displacement, so will not be negative. And total time we have found that this t is 14.8, so total time is 14.8. So meter per second. So this would be equal to, let me calculate. Okay, so it would be 0.97297 meter per second. So we'll round it off to three significant figures according to the requirement, meter per second. So this is your answer for this part. And the question number, which question number is this? I forgot. Sorry, this question is finished. Okay, this is question number 5. And the different forces are given to you. And this is 10. 4 coplanar forces act at a point. The magnitude of the forces are F Newton, 10 Newton, 50 Newton, and 40 Newton. The directions of these forces are shown in the diagram. Given that the forces are in equilibrium, so body is in equilibrium. Find the value of F and the value of theta. So you have to find out the value of F and the value of theta. First of all, we'll resolve all these forces. So this force first, its direction is this one. So its impact would be this one, and horizontal and vertical component would be this one. So we'll write down its horizontal component, that would be F cos of theta, and vertical component, that would be F sine of theta. Okay, so next is this one. Its horizontal component would be this one in this direction, and vertical component would be in this direction. So this is F 40 cos of 60 degree, and the vertical is 40 sine of 60. So keep this thing in your mind that the opposite is sine and adjacent to the angle is cos. Like adjacent to the angle is cos and the opposite to the angle is sine. Okay, the other forces are already in the horizontal and vertical positions. I mean, this 10 and 50 are already in the vertical and horizontal situation. Okay, so we'll make a box to write down all these so that we don't do any mistake. So in this direction, there is force F cos of theta. So F cos of theta. Also, we have a force 10 Newton in this direction. So 10 Newton. I've learned this method from my teacher. So he told me to do it. So that's very useful. You don't do. Cannot leave any force while solving the question. Okay. In the opposite direction to this one, this force, horizontal component, negative x is 40 cos of 60 only. So this is 40 cos of 60 degree. Okay. And the upper forces, upper direction, this direction, there's f sine of theta and 40 sine of 60. So f sine of theta and this is 40 sine of 60. Okay, and this is 50 Newton. Okay, 1, 2, 3, 4, 5, and 6. So let me count down 2, 4, and 6. Okay, so we have not left any of the forces. Okay, so opposite forces are equal as it is in equilibrium. So this is equal to this one. So F plus F cos of theta, F cos of theta plus 10 is equal to 40 cos of 60. And number one, we have taken the horizontal forces. So F cos of theta is equal to this is 40 cos of 60. If you use the calculator, this is 20 and this force will be subtracted, 10 will be subtracted. So F cos of theta is equal to 10 Newton. Okay, so you got the first one, this one. Then we'll use the vertical forces. Their sum is equal to 50. So F sine of theta, F sine of theta plus 40 sine of 60 is equal to 50. So F sine of theta is equal to 50 minus 40 sine of, here I have to use the calculator, so you have to wait a minute. That would be, okay, so this would be 50 minus 40 times 60 sine. So this is 15.36, 15.3589. 3589. Okay, so this is the second one. So if we use first and second, from first and second, F sine of theta over F cos of theta is equal to 15.3589 divided by 10. F would be cancelled and tan theta is equal to 1.53589 and theta is equal to tan inverse 1.53589. Okay, theta is equal to, let me do the calculation. Okay, so divided by 10 and inverse tan. So this is 56.9. So 56.9 degree. So you got the value of theta 56.9. This is your first answer. Now you have to find out the force F. So this is your answer. Okay, so we have to find out the force F by taking this equation. F cos of theta is equal to 10. We'll find out F cos of theta is equal to 10. F cos of 56.9 is equal to 10, and F is equal to 10 divided by 56.9, cos of 56.9. 10 divided by 56.9 cos, this is 18.31, so it will be rounded to 18.3 Newton. So the force which you are supposed to find out, F, that is 18.3 Newton. Hope you have understood this question. Okay, this is part B of the same question. So they are saying if F is equal to 10 square root of 2 and the theta is 45, find the direction and exact amount of the resultant force. Right. So this is, so we have to go back to the situation that was we found that the horizontal component would be this one, right? So these two forces minus, this is in the opposite direction, minus this forces would be the horizontal component x, right? So x would be F cos of theta plus 10 minus 40 cos of 60. So let me, I think, copy down this diagram there so that we can feel easy to understand. Okay, so this is the diagram. So what we are going to do will the horizontal component is F cos of theta plus 10 and minus 40 cos of 60 degree. So F is 10 square root of 2, 10 square root of 2 cos of 45 plus 10 minus 20, and this will become Ox is 10 plus 10 minus 20, and this is 0 Newton. So horizontal component is 0. Next is vertical component. So positive y minus negative y, this one, F sine of 60 plus 40 sine of 66. F sine of 60 plus 40 sine of 60 minus 50. So this will be F is 10 square root of 2 sine of, sorry, this is F sine of theta. F sine of theta, and theta is given now in this one, this is given 45. So 45 degree, and this is again 40 sine of 60. Let me find out what is this 40 sine of 60. Forty sine of 60 is 40 40 multiplied by 60 sine, and now this is not the exact value. That's not this, actually not in the square root form. Let me find out. I'm using the calculator from my, okay, 3.46. No, I'm not going to find out the exact. So you're not going to put the value, actually, sine 60, sine 60, 60, sine 60. No. So it's not working. 3.464 and minus 50. Let me confirm it again. 40 multiplied by 60 sine equals to, this is 34.64. So 34.64. Okay, and this is 10 plus 40, 34.64 minus 50. So 44.64 minus 50 is minus 5.36 Newton. So OY is negative 5. That means we found this one if this is OY and this is OX in this direction. So if that is negative, OX is horizontal component is negative, that means that is in this direction. Now this OY is negative, that means this is in this direction. Okay, so we'll write down resultant force is equal to 5.36 Newton in the direction of 50 Newton. Got it? Okay, this is question number 6, and you are given this diagram in which two particles P and Q are on the surfaces. Two of the particles P and Q of masses 0.2 kg and 0.1 kg are attached to the ends of the light inextensible string. The string passes over a fixed smooth pulley at B, which is attached to two inclined planes. The particle P lies on a smooth plane AB. This is smooth, which is inclined at 60 degree to the horizontal. This angle is given 60. Particle Q lies on the plane BC, which is inclined at an angle theta to the horizontal. The string is taut and the particles can move on lines of the greatest slope of the two planes. See the diagram. It is given that theta is equal to 60. If this is given in the part A that this is 60 degree, this angle is 60 degree, and one thing, this is 60, and the BC is rough, and the coefficient of friction between Q and the plane BC is 0.7. The particles are released from rest to determine whether the particles move or not. Okay, first of all, we'll find out in this direction the force of Q. That would be uh, mg sine of theta, mg sine of theta. That would be 0.1 into 10 into sine 60. So that would be equal to sine 60. So this is the force, driving force of Q, and the driving force of P, if it is on this side, it is mg sine of theta again. So this is 0.2 into 10 into sine 60. So this is 2 sine of 60 degree, right? And what is this is, this surface is rough and the coefficient of friction is given, mu is equal to 0.7. So what would be the R? R would be mg cos of theta, mg cos of theta. So R is equal to mg cos of theta. That means this is equals to mgm is 0.1 into 10 into cos. In this case, theta is going to be 60. So you can say R is equal to cos of 60. So what would be the frictional force? That would be limiting frictional force. That would be mu R, and this is F limiting is 0.7 into cos of 60, and cos of 60 is 0.5. That will become 0.35 Newton. Okay, the friction is 0.35 Newton. So uh, let me add another page. Driving force towards P. Driving force towards P is equal to 2 sine 60. Okay, that is 2 sine 60. Let me use the calculator. 2 multiplied by sine 60 is 2 multiplied by sine 60. This would be 1.732 Newton. And driving force towards Q is sine 60, right? So we have done it with the sine 60. Sine 60, and the sine 60 is 60 sine. This is 0.866 Newton. Okay, so as this force towards P is more than this, so friction will work in the it will try to move downwards because this is more than that. This is 1.732. 1.732 Newton, and this is 0.866 Newton. So this force is less than this. So the object will try to move down, and this will try to move up, and the friction will work in the opposite direction. It will not let it go up. So, and this will be the force which is working in the opposite direction. So opposite direction, this is 0.86 plus 0.35. So we'll check total opposing resistance force. Driving force is now 1.732, and resistance force force resistance is, let me do it, force driving, sorry, and force resistance is 0.866 plus that is 0.35, the frictional force 0.35. So let me find out what it would be total. Okay, this is plus 0.35, so this will give you 1.216. This is still less than the driving force. So that means driving force minus resistance force, driving force minus resistance force is equal to 1.732 minus 1.216, and this is minus 1.732. This is 159, 0.5159. Okay, 516, that was the previous actually Newton. So this is greater than zero, positive. So the particles will do move. Particles, particles will, particles will move. Okay, because they ask us whether they move or not. So they will move. And what would be the particle's direction? That would be in the direction of A. So towards A. You can write it this as well. Towards A. Okay, so this is your answer. Hope you understood. Okay, the part B, it is given that instead the plane BC is smooth. Now this plane is also smooth. The particles are released from rest and in the subsequent motion, the tension in the string is square root of 3 minus 1 Newton. Find the magnitude of the acceleration of P. Uh, it moves on the plane and find the value of theta. So we have to find out the acceleration and the value of theta. So tension, you know that this amount was the driving force for P was we found it here mg sine of theta, that was 1.732 Newton. So this will not be changing because this angle is same. So this will be 1.732 Newton. Let me recheck. This is 1.732 Newton. Yes. So 1.732 Newton, and the driving force for Q would be mg sine of theta. That would be, this was also mg sine of theta, and this is equal to this one. So 0.1 into 10 into sine of theta. We don't know the angle now. We have to find out. So this is equal to sine theta. And now we are given the tension here. This is the tension in the cable. So tension, as you know that this object was to move downwards. So the tension will oppose this motion, and here it will just hold on. Yes, the motion will be on this side. So tension will oppose, and also tension's direction will be on this side for Q as well. Okay, so we have got two functions. This is driving force is this one, resistance force is this one, and that is equal to MA. So for P, particle, driving force minus resistance force is equal to force net, that would be equal to MA. So driving force is 1.732 and resistance is the tension, which is square root of 3 minus 1 is equal to 0.2 A. So this would be A is equal to, if you do the, let me use the calculator. So this will become, okay, 0.4999 Newton. This is A is equal to zero point 0.5 Newton. Let me confirm again. 1.732 minus square root of 3, 1.732 minus 3 square root and plus 1 and divided by 0.2. So this will be 4 point, sorry, this is 4.99 Newton. Okay, this will become 5 Newton. Acceleration is, sorry, not Newton. This is actually, the time is midnight, so I think I'm feeling sleepy. Okay, I'm doing mistakes. 5 meter per second square. We got the acceleration. Now we have to find out the theta, so we'll use the this function. In this one, this is the driving force, tension is the driving force, and the inclination force of Q is the resistance force. So driving minus resistance, force driving minus force resistance is equal to MA. So we'll substitute this tension is square root of 3 minus 1 and no need to put bracket, minus sine theta is equal to 0.1. Now we know what is A. So sine theta is equal to square root of 3 minus 1 minus 0.5. So theta is equal to sine inverse and this is square root of 3 minus 1.5 and theta is equal to, let me do the calculation. Okay, square root of 3 square root minus 3 square root minus 1.5 inverse sine. So this is 13.4 degree. So this is your answer for the angle theta. So we were supposed to find out the acceleration of P. So we have found the acceleration of P by using the system of moving system of P, and then we found the angle that's obviously with this system. So we used this system. In this system of motion, this is driving and this is resistance. And in this system of motion, this is driving and this is resistance. T is tension is resistance. Hope you have got it. Okay, this is question number 7. A car of mass 1200 kg is traveling along a straight horizontal road. The power of the car's engine is constant and is equal to 16 kilowatt. So power is given 16 kilowatt. That means 16,000 watts. There are 1000 watts in 1 kilowatt. So this will become 16,000 watts. Mass is 1200 kg. And next they are saying there is a constant resistance to motion of magnitude 500 Newton. So this is the resistance to motion. That means force resistance is 500 Newton. Then find the acceleration of the car. So we have to find out the acceleration at an instant when the speed is 20 meter per second. So we are given that speed is equal to 20 meter per second. Okay, you know that force is equal to power over velocity, and this is the driving force, right? So driving force will become equals to 16,000 divided by 20, and this will become 800 Newton. So we'll use the Formula: driving force minus resistance force is equal to MA, net force. Driving force is 800 Newton, and this is constant 500 Newton, and 1200 is the mass, and we have to find out the acceleration. Acceleration is equal to 300 divided by 1200. So this is meter per second square. So this will become A is equal to 1 by 4. This is 0.25 meter per second square. So you got the acceleration. This question is solved. This part of the question is solved. And next part B is assuming that the power and the resistance forces remain unchanged. Find the steady speed of at which the car can travel. Steady speed means constant speed. If the constant speed is constant, that means driving force is equal to resistance force. And driving force would be power over velocity. And resistance force is fixed 500 Newton, right? And power is given 16,000, which is, he's saying, unchangeable, and this is equal to over V. Velocity is equal to 500, velocity is equal to 16,000 divided by 500, and that will be equals to, cancelled, 5 3s are 15, 5 2s are 10, and meter per second. So you got the velocity at which it can move if there is the speed is steady and there is no acceleration, then it can move with 32 meter per second. Okay, this is the last part C of the last question. The car comes to the bottom of a straight hill of length 316 meter, inclined at an angle to the horizontal, sine inverse 1 over 60. Okay, so we'll draw a diagram. Okay, this is the top of the hill. Let's suppose this is point A. At this point, this is the bottom of the hill, this is point B, and this is the perpendicular height, and this is 316 meter distance. Okay, so the length of the inclined hill, straight hill, is 316 meter, and the angle is sine inverse 1 by 60. Sine inverse 1 by 60. So the height is, you know that sine theta is equal to h over 316. So h is equal to 316 sine theta, and theta is sine inverse 1 by 60. So this will become 316 into 1 over 60, and this will become 316 over 60. So you got the height of this. Okay, so the power is still constant, 16 kilowatt, but the magnitude of the resistance force is no longer constant, and changes such that work done against the resistance force in ascending the hill is this one. So work done by resistance force is given to be 128,400 400 joules. Okay, this is given to you. We'll highlight this because we have to use it in the next one. Okay, now the next is the time taken to ascend the hill is 15 seconds. This is 15 seconds is the time. Given that the car is traveling at speed 20 meter per second, time is equal to 15 seconds, and at the bottom speed is 20 meter per second. Here this is 20 meter per second at the bottom of the hill. So V is equal to 20 meter per second. Power is equal to 16,000 watts. Okay. The next is they are saying find the speed at the top of the hill. So we have to find out the speed at the top of the hill. So we suppose that speed at the top of the hill is V meter per second. Okay, now you know that power is equal to work done by the driving force, work done by driving force over change in time is equal to power, and this will be equal to 16,000. Work done by the driving force, that will become equals to 16,000 into the time is 15, and this will become work done by the driving force, that will become equals to, let me calculate it. Okay, 16 into 16,000 into 15 is equal to 240,000 joules. Okay, so we'll use the work energy formula, that is work done by driving force minus work done by resistance force is equal to change in kinetic energy minus change in potential energy. So now we'll find out the change in kinetic energy. Change in kinetic energy is equal to half kinetic energy at point A minus kinetic energy at point B. Right? What is the kinetic energy at point A? That is half mv square. M mass is 1200 kg, and v square minus half m 1200, and at the bottom the speed is 20. So this will become change in kinetic energy will be equals to 600 v square minus to 6 at 12, this will become 600 into 400, this will become 240,000. Okay, so now we have to find out change in potential energy. So change in potential energy. So that is potential energy at point A minus potential energy at point B. So at point A, this is mgh, h is this one. So at point A, mgh 1200 into g is 10 into h is, that's 316 divided by 60, minus potential energy at B is at the bottom, so height is 0, so that would be 0. Now let me calculate this. This is 12,000 into 316 divided by 60. So this will become 63,200. Okay, this is change in potential energy. So now we'll write down the formula and substitute in that. Work done by the driving force minus work done by resistance force is equal to change in kinetic energy plus change in potential energy. Okay, work done by the driving force is this one. This is 240,000. I think this is 240,000. 16 fives are sorry, this is 15. So this is 240,000. Okay, so 240,000 minus work done by the resistance force, that is given to be 128,400. So 128,400 is equal to 600 V square minus 240,000 and plus 63,200. Okay, let me do the calculation. 240,000 minus 128,400, so this will become 111,600 is equal to 600 V square, and this is 63,200 minus 240,000 minus 176,800. Okay, so 600 V square is equal to 111,600 plus 176,800. So 111,600 plus 176,800, and this is, if we divide it by 600, V square is equal to 480.6667. If we take the square root, this will become 21.924 meter per second, and if we round it to three significant figures. This will become 21.9 meter per second. So hope you have understood the concept. This paper is finished. Now, inshallah, I'll be starting the pure mathematics 1 variant 2 of May June 2023. The next would be that paper.